Every A-level paper seems to have what I call a novel calculation, something you've probably never seen before, something like this. When 2-methylpentane reacts with bromine, some of the hydrogen atoms are replaced with bromine atoms. 0.8649 grams of the product of this reaction was vaporized. We get a volume of 72.0 centimeters cubed when that happens. Determine a possible molecular formula for the new compound, given that its molar gas volume is 40 decimeters cubed per mole. These questions are always very, very poorly answered in the exam because our initial reaction is, well, panic. However, a little bit of logic and we'll be able to figure out what's going on. The key is to go back to the question and find the information that's going to get us started. So what do we know? Well, when they vaporized a sample of this molecule, they got 72 centimeters cubed. We also know the molar gas volume. But what is a molar gas volume? Well, this is where units are really useful. 40 decimeters cubed per mole. 1 mole occupies a volume of 40 decimeters cubed. When they vaporized the sample, they didn't get 40 decimeters cubed. They got 72 centimeters cubed. But I can use this information to find out how many moles were in that mass. All I need to do is divide 0.072, that's 72 centimeters cubed in decimeters. I've divided by 1,000 by 40, and I get 0.0018 moles. What else do we know? Well, we know the mass of the sample that was vaporized. If I know the mass and I know the number of moles, I can work out the molar mass of our new molecule. All I need to do is divide 0.8649 grams by the number of moles, and it comes out at 480.5 grams per mole. So this is the molar mass of our product molecule with some bromine atoms. We need to figure out how many. I'm going to go back to the question, what else do I know? Well, I know that my starting molecule was 2-methylpentane. I can draw that out and I can figure out the molar mass, 86 grams per mole. So I know the molar mass of my final product. I know the molar mass of my starting material, and the difference is 394.5 grams. That difference must be due to the bromine atoms that were added during the reaction. Using my periodic table, I can find the molar mass for bromine, 79.9, and if I simply divide 394.5 by 79.9, I get 4.9. My new molecule has 5 bromine atoms, 5 hydrogen atoms were replaced. And our final molecular formula is C6H9Br5. The trick to these questions is don't panic, start with the information given in the question and figure out one thing at a time. You can find notes, practice questions and so much more at Crunch Chemistry, everything you need for A-Level.